Good morning, good afternoon, good evening. Welcome to Devtoberfest Week 3. This is the first presentation of Week 3, and the topic of Week 3 is Cloud Native. We had a brilliant chat with James Governor from Redmonk on Friday, talking about best practices in the Cloud Native era. And that, for me, was a really nice sort of segue into this key main week all about Cloud Native. Now, if you're wondering why you've got my ugly mug here, it's because this is going out. This is Josh Bentley's week. Josh Bentley is running this week of Cloud Native, but where he is right now, it's 3 a.m. So I'm hosting this, and I'm very, very delighted to, because with me, I've got Jens Keller. Say hi, Jens.
Hey, hi, everybody.
Welcome, Jens. And Jens is going to talk to us about microservices. Apparently, according to Jens, but I think, I'm so looking forward to this talk, one of the most misunderstood concepts in software, in the software industry. So Jens is going to be talking to us about the details of that. I'm going to hand over to Jens in a couple of seconds. Jens is going to tell us all about himself and then just launch straight into the presentation. We're going to take up to an hour. So, we're going to go with a full 60 minutes. Whenever you've got questions, stick them in. I'll try and write them down, and we'll save the questions to the end. But also, if we, if Jens or I ask you some questions, feel free to respond to those questions, respond to any sort of, what do you think about this? What do you think about that? We may or may not do some of that. But without further ado, I'm going to hand over to you, Jens. Welcome and thank you.
Cool. Thank you very much. And I'm also going to share my screen straight. And there you go. So I hope you can all see the presentation. Maybe DJ can give me a quick feedback.
I can see the presentation.
Perfect. All right, cool. So topic of the talk is microservices are probably not what you think they are. My name is Jens. I'm also from SAP. And just jumping here onto the agenda first, before I also quickly introduce myself, we'll first talk about some common misconceptions. Then we give a practical example, talk about then the goal of microservices, which is probably one of the things which you find surprising. And then we'll also talk a bit about the implications to Agile Organization. That's the plan for this session here. And talking about me a bit here. So my name is Jens, as I mentioned already, and I worked in several roles in various product organizations, mostly in engineering. I had a developer, lead developer, architect, infrastructure roles, but I also worked as product owner and Scrum Master. I'm familiar with all kinds of development, front-end, back-end, cloud operations, worked on the persistence with SAP technologies, non-SAP technologies, and for quite a while, I'm also working as a trainer and coach for cloud native development. That means I get to see many, many development teams, many product units, different technologies, and also get to see what teams struggle with. And especially when they are transforming to the cloud, you see one particular challenge that comes up, and that is something that I also find is happening not only inside SAP, it's also happening outside SAP, that sometimes people have different understandings of the term microservice, and it maybe already starts with the term itself, which bears a lot of potential for misunderstanding. So that's what we're going to explore a bit in this talk. What do teams struggle with? So for the opening, I got a few things for you to reflect on. You can also give some feedback in the chat if you like, for sure. So I would be wondering whether you guys who are now on the stream while watching that video, how big is the team you're working in? Are there other teams you are working with? And if so, how many other teams are you working with? And I was also wondering whether you ever suffered from dependencies, no matter whether these are technical dependencies or people dependencies. So you can give some feedback in the chat. And while we're waiting for some feedback in the chat coming in, I just show you a few things that I get to see whenever I work with different teams. This is a common situation everywhere. Wherever people work in the cloud and in a big organization, they struggle with those things. These are common issues. They upgrade the lib to a new version and it creates this trouble. Somebody says, from the team says, I'm currently blocked because the framework has a bug. Then another guy says that I couldn't finish the story because the other team's API was not yet ready. I cannot continue because the build breaks for some other component, which is maybe also not from our team. or the ops team is still working on the deployment and we need to wait. And you can imagine there's a lot of such situations in everyday life where you kind of are being blocked or are waiting for something outside your team to happen. And after all, people are often frustrated by this. This is a pretty common situation. So DJ, I'm not sure whether there are any responses in the chat from people, whether this is a familiar situation, whether people also suffered from dependencies.
Yeah, so we got some great feedback in the chat already. Mohammed has said that his team size is 50, and there are 2 other teams as well. Seems quite a large team size to me. I mean, but then Zeitiger is saying something between 1 and 8 people, in average 3 to 4. Andrew Diaz says 10, and also says, yes, dependencies are very common. And Duma is also saying, yes, have suffered from dependencies, both technical and human. I've never thought of dependencies being human before, so that's fantastic. Ashish just randomly says, good morning from Mars. So welcome to Mars, Ashish. Uwe Fetzer is saying his teams are between 6 and 10. Mohammed is saying, yes, definitely there are dependencies, both technical and people. Yes. So yeah, I think this is resonating a lot.
True. Yeah. It's a common situation. I mean, that was even there before the cloud world. In the cloud world, it maybe just looks different. The reason why we have those dependencies is because we want to scale. I mean, we are going to work on a bigger product. And if you're just going to work with like 2, 3, or 4 people, it's going to take forever. So we somehow want to scale. And by that, we are setting up more teams. We are staffing people. We're trying to get them onboarded. And then we try to also distribute the work. Different people get to do different things. Different teams are getting to do different things. And that kind of also creates then sometimes dependencies, because after all, we're working on something together. So there must be some dependencies, no matter what. And the technical and the people side is always there. That's also like what Conway's law is telling us, right? There is a technical perspective, which is the architecture side, but then there's also the organizational perspective, which is more the people side or the process side. So you can't really separate those things. You can't have the one thing without having the other. It's just not possible. It's a common situation. So, but how is that related now to microservices and cloud native? And what are some common conceptions or even misconceptions that people tend to have on microservices? So here are some common terms. When people say we are developing microservices, they say our apps run in separate processes, which is true. That's not wrong. That's a true statement. That's what microservices are supposed to be. Sometimes people are saying our apps are 12-factor apps, so that's why we are building, that means we are building microservices, obviously. Another typical statement is we are cloud native because we use Kubernetes as a target platform. More statements, what's more, continuous delivery. Sometimes people say we have a deployment pipeline. That means we are doing continuous delivery. Another person would probably say that we are doing DevOps because we have a team or a person who takes care of the operations. And then people might also feel that the DevOps engineer is maybe a dedicated person responsible for the operations, often maybe not a developer or part of the dev team. And none of these conceptions are entirely wrong. The point is just they miss the bottom line. So here's the thing, the typical problem with those conceptions is that when you talk about microservices and say our apps run in separate processes, many of them have the issue that it makes them slow. And I wonder why that is. Is that an intrinsic thing, or is it just that something is going wrong there? Next statement was our apps are 12-factor apps, but maybe still they need to be deployed together. So maybe they are not decoupled enough. We need to deploy the whole thing. So what is the benefit we got out of it then? And then if we use Kubernetes as a target platform, might still be that the customers don't even care about that. So that's just the technology. So does it mean we are cloud native if we just use a particular technology, or is there more to it? Same with continuous delivery. We might have a deployment pipeline, but what if the developers don't even want to manage that pipeline? What if that pipeline is slow? What if that pipeline is even kind of, like unstable? And with DevOps, the same thing. Maybe we have a team or person takes care of the ops, but maybe it's centralized because the operations complexity is so high. So are we then still doing DevOps? Maybe yes, in theory, but are we really following the mindset behind DevOps? I'm not sure about that. And when you think about the DevOps engineer, if that's a dedicated person responsible for operations, and if that is in a centralized team because the operational complexity is so high, then it might even be that this DevOps engineer has not even any clue what he or she operates. So what's the key problem behind all these things? So to get better grip on that key problem, what we're going to do is we're going to have a look at a practical example now. So for this practical example, I'm going to show you a very, very simplistic little application here. It's just for demo purposes, so just complex enough so that you get the point behind. So we have here a little bulletin board application. So just something where you can advertise something. You can post something that you would like to sell. And if you post something, you would go here to this little microservice here, which is called bulletin board ads. You post your advertisement here. It has its own database. It runs in its own process. So you could say it's a little microservice, follows also the 12-factor principles. For example, it's RESTful and all those things here. We got another one here, which is called bulletin board reviews. So whenever you purchase something from someone, you can also leave a review for that person, which also runs in its own process, and it has its own database. So everything is cool, everything is nice. You see the end user up here interacting with both the applications, maybe looking at the catalog or creating a new ad or writing a review or looking at the reviews. And you see also there is a connection between those two services here. And that's already a manifestation of a dependency. You can see it here. We are making a synchronous call. That means if you would like to display our advertisement, we would also like to get the average ratings of a user, of a particular user who has posted that thing. And we might get a JSON response back here, which says this particular user has an average rating of 3.375, whatever that means. So what I'm going to do is I'm going to switch on over to my browser, and we're just going to have a look at the little application. You see it here is running locally entirely. Both the services are deployed locally. And you see, I've just created one demo entry here. So I'm just a user who would like to browse a catalog. And you can see here, there's one offering. And if I look into that offering, you see also there is a color here for that user who is offering this, this product here. So when I look at it, I can take a look here, this user, and kind of have a look at the reviews of this person here. And you can see there are no reviews yet. And if I just go back to the start page here, I can tell you the reason why this user is colored in red over here is because that user didn't get any reviews here. So the logic is if someone doesn't have any reviews, or if someone has only very poor reviews, then it's not considered a trustworthy person, so to say. So the color we are giving over here is red. Now, if I would add a new review to that user, or if that user received some reviews which are of a good rating, then the color might change into orange or even green, which gives me as a potential customer now a good indication on whether that person is trustworthy without navigating into all the details. All right. So that's a scenario. And you can see here, in order to do that, we are getting the information here, of course, from the other service. It's a detail whether we get them like on the fly or whether we are synchronizing in the background, but we are making definitely a synchronous call over here. All right. So the problem we're having here is we have tight coupling between those services. We have to have some sort of coupling. We need those ratings because we want to have those ratings to kind of give a good indication of the user's trustworthiness. So we have a business requirement here. We cannot eliminate the dependency entirely, but the way the whole thing is designed, maybe there's room for improvement. I show you some issues that we have with that little service. So if I just go over here to my IDE and just stop the review service. So I'm here in the process where I started the review service. And if I just stop it, just like so, I just cancel the process. And now I go back to my browser and try to reload. And what you can see here, I get even a failure. We're failing to load the advertisements. And the reason why we are failing is because we can't get the rating of that user. So what we're having here is a tight coupling over here. That means we can't do that feature without the service here being up and running. Now, you could do a lot of things to improve things. Of course, you could build in some resilience for it. So, for example, make the call, but if it fails, then have a default value. You could do things like this, but still there is more issues. What, for example, if the response of this service here is slow? So that's another trouble you're having then, right? Again, you could think about resilience. You could think about rate limitations or circuit breakers if you know about all these different concepts. So there's a lot of things that you can do to improve. But then there's even other issues. There's also, so to say, a people dependency, or you could also say a dependency in the sprint backlog. If over here we have another requirement in the future where we need some information from those reviews, maybe some specific information, we need to have a different calculation. Maybe in the future, we not only want to have the average ratings, we probably also want to have like the best rating or the worst rating of a particular user. This creates a dependency between the two teams. The team over here would like to put that story, but they need the API from the other team over there. What if the other team doesn't have time for it? Because maybe they receive requirements from some other teams as well, and they also have to prioritize their backlog. And they would get back to this team and say, sorry, we can't deliver this API in the next sprint. You could now say, okay, please, can you try? And then you end up in the situation that we just had on the slide before, where you kind of say, well, we can't complete the story because they haven't delivered the API that we needed on time. So you see this whole design over here creates a bunch of problems that we are having. What if we could solve it differently? Let me just first bring that service here back up. And after the service is back up, you could see that again, things are loading over here, okay? So what I'm gonna do now over here is I'm gonna solve the problem by changing the communication. What I'm gonna do is, instead of getting the information from here and getting even a very specific information from the service over here, what I'm gonna do is I'm gonna make a change over here to expose an event. I'm gonna publish an event whenever a new review is being written, and I publish that event to a message queue, just right here. And over here in this service, I'm gonna listen to that message queue, and I'm gonna receive the new review. And what I'm gonna do is I'm gonna store the ratings or the average rating over here in the database. That means we have a little bit of a redundancy here. We have some rating information over here, and we also have some rating information over there. Actually, the rating information here, we don't even need to keep. It's more like the average rating that we're interested in. So we could also, if we wanted to, store only the average rating. Still, it's kind of a little bit of a redundancy because the average rating we are storing in here should be a result of the ratings over there. But it improves also many things, and we're gonna talk about that after we're done with it, all right? So let me just switch over to the code. I've prepared most of the things so that things are also going a bit faster over here. So first off, I'm gonna here go over to the bulletin board reviews. The code is here. And what I'm gonna do is here, I'm gonna have a look at my server code, and right here in my post endpoint, where I receive the event when the user writes a new review and clicks send in the browser or save in the browser, then I'm not gonna only store it here in my local database, I'm also gonna publish an event to a message queue, which is over here. So I just comment that in. The service is already connected to the message queue, so I've prepared that in the background, all right? So the other thing I'm gonna do is I'm gonna switch over to the add service, and in the add service, in my main, I've already configured the consumer to the message queue, which is over here. And in that consumer, I will receive the event, I will receive the new review or the new rating. And what I'm gonna do is over here, I'm gonna store those things locally. So I'm gonna go to my Postgres database of the add service and store the new rating and update the rating of the user over here. So just gonna comment these little lines in there. And we're gonna have a quick look into this update rating function here, which I've also already prepared. So the update rating function looks like this. Over here, we are going to insert the new rating into a local table that is really now local to the ads service. Then we are also calculating the average rating based on the information that we have in the table now. And we are also storing the new average directly in the advertisements table. Okay, so that means I've done also a little extension to the advertisements table over here already. That means I've added a new field here into the ads table, which is called average rating. Okay, so that's what I've done. So let's just make these code changes live by restarting the services. So both services are now being restarted, and I'm already connected to the DB over here. And you can see over here, we have one entry here in our database. The average rating is not written yet because the message queue was not in place so far. We can also have a look at the ratings table, which I just mentioned. So this is a database of the ads service, which is empty. So now, as you've seen before, I've uncommented some code which will publish an event to the queue on the review side, and I'm consuming that event on the ads side, and I'm gonna keep the ratings and the average rating local then on the ads side. All right. So when I now go back over here, and I'm just gonna write a review now for that person, add a new review. Just go with some default, and we give it a rating of, how about 4? Let's just save that. And the review has been created. And let's now have a look in our tables here again. And you can see here, we got a rating now over here in the ads service. And if I now have a look at the advertisements table, now also the average rating was updated here. So that's cool. So what can we do now with this information? Now we can make the significant change in our ad service. We can go here to our server, and in our server, where we are displaying the ads, you see over here, this is the code that caused the trouble before. Here in our ads, we always reached out to the review service to get the average rating. Now we don't need that anymore because we got the average ratings asynchronously through the message queue. That means we have them locally. That means I can uncomment this line here and rather get the average rating, the average contact rating over here from my local database table field, which I have here. Oops. Right here. So let's see if that works. Let's start this one more time. Service is started, and we go back to the ad service. Here. You can see here it's green. That's because we've written the review now. But now there will be one thing which will be a significant change. If I now go over here and just stop the review service, I just put it down. Take it down, the review service is now not there anymore. It's like it has an issue, maybe it has an error, maybe it crashed in my cloud environment, whatever happened. But now the ad service is still working. You can see it's still loading, no problem whatsoever, because it uses the data which it has locally. So let's go back to the slide over here. So what we have done now here is we've changed this into that. We are now publishing a new review here through a message queue in an asynchronous fashion. And over here, we are then having some rating information, at least the average rating, whatever we need locally in the database over here. So what this changes is it gives us several advantages, but it doesn't come for free, as you probably already spotted that. So what we get is we get a much better performance because now when we browse the catalog, everything is locally. We have also now a better decoupling because this service here is not needed and this service here does not make the call to that service anymore. So I can deploy that individually. The thing is also more resilient. So if that is not available, if this one here is slow on the review side, then everything is still working as before. So we get some resilience here for free. It's also easier to scale because if I have a bottleneck situation over here and more users are browsing the catalog, I can scale this service without this service becoming a bottleneck. Maybe there's even more advantages that you're having. One drawback you're having is you have now this eventual consistency. That means you have to worry with the updates. What if new reviews coming in over here and then the data here is not up to date? Turns out in real life, that's often not such a big problem. We tend to think as developers that things must always be consistent because that's how we've been educated in the past, in database classes and in whatever. But when you ask for the business requirement, very often you can live without it pretty well. If over here the reviews are being updated and the average rating is updated a little bit later, it's not a big deal. You have this even already, even in the original picture before, if I go back to that over here, it might be that I look at the catalog and are browsing to the reviews page and look at the average rating of a user while another person is just writing a poor review for that person. That might happen at the same time, but I've already loaded the data in my browser, right? So that means the data I have in my browser is also not consistent with what might be in the database over here 1 millisecond later or even 1 millisecond before. So this eventual consistency is usually in real life, it's already there. We can't do anything about it. And that's why in reality, we can very often live with these things pretty well. Also, if things are slightly off, if you miss an update over here or over there, you certainly got to think how you deal with that situation, but you also got to wonder how critical is it? And depending on how critical the situation is, you can have different strategies. The strategy I'm showing over here is not the only strategy. What you could also think about is do a lazy load, for example, over here. So load something from here to update the cache in the background, which means you have a local cache over here where you always take the data from, but while you are reading it, just also fire another request in parallel in the background, so it's still asynchronous, so that you can later on also update your cache over here. But this you can have the cache over here much more robust and becoming consistent over time automatically. It's also not necessarily that you always have to persist it even in your database. Sometimes it's even fine to keep it even in memory. So there's different strategies that you can have to implement this pattern. But at the core of it is that you are decoupling the services and get several advantages from it. And if you go for this more generic approach, where over here you also just publish the review event as such, that means also from the team perspective, we decouple things a bit, because now we are subscribing to an event where we get all the review raw data. Right now, we are only storing the ratings or maybe only the new average rating or whatever that is. But maybe in future, we could do other things. We could also take this and also persist the max, the best rating or the worst rating over here. We don't need all the features now being done by this team anymore. They just give us the raw data and we can enrich that data and contextualize that data. So in whatever ways we need. So that also decouples us from a Scrum or Agile perspective. So now that brings me now to the topic, what microservices really are all about. The key problem is coupling. And often people create a microservice architecture which is too coupled, but that is not the goal of microservice architecture. The goal of a microservice architecture is to maximize the speed. It's not to minimize the cost. Sorry, it's a typo. It's not to minimize the cost. People think it's about reusing things, but microservice architecture is not so much about reusing things. It's rather about maximizing the speed. You want to enable teams to move fast and get their stories done fast. That means in a microservice architecture, you are aiming for decoupling instead of reuse. You are trying to embrace, you are trying to accept that there is some redundancy in the data. And in order to minimize the coupling, you got to do two things. First, you got to make sure your microservices are domain partitions, not technically partitioned. And domain partition means they are partitioned along business domains or subdomains. They are not organized along technical layers because you want to decouple them. If you have a microservice for the persistence and a microservice for the domain logic and a microservice for the UI, then this is coupled, this is not decoupled, because whatever you do in the UI, you probably need something from the domain layer. Whatever you do in the domain layer, you probably need something from the persistence layer. So microservices should be rather domain partitioned, not technically partitioned. And the second thing is to further minimize the coupling is you gotta embrace data duplication, eventual consistency, and asynchronous communication. So I got a picture here of on the right. From what we've just seen before, we have now these different contexts. They are so-called bounded contexts. These are forming subdomains. You could say this is a subdomain of the advertisements, and this is a subdomain of the reviews over here. So you see clearly these are business domains. But when my review service, when I think about my review service, it has everything. It has a UI part, it has a domain part, it also has a persistence part. So it is domain partitioned, and we also have some eventual consistency probably over here. For example, when we think about user information or product information or some rating information in that particular case, you see the rating information here, but the rating information is also part of the reviews over here. So you see there is some data application, which brings us to this eventual consistency and to this asynchronous communication. So that's the trade-off you are making. If you have a true microservice architecture, you rather favor the trade-offs for speed instead of favoring the trade-offs for reuse. It doesn't say that you are not reusing at all anymore. Of course, there will still be a little bit of reuse, but if you want to get the best out of microservice architecture, you gotta rather aim for decoupling. That means to accept some deprecation. That's the biggest difference to the previous architecture styles. What I also want to share with you, if you have a look at Kima, for example, and look for some learning material from Kima, I've shared a nice link here for building an application in the Kima runtime. When you follow this tutorial, it will also show you the same pattern. We are going to write a little application that is going to connect to another application, which is a commerce application, and it will consume an asynchronous event. And you're going to consume that event and going to store something locally in your local database. And then you can do your story. You can create your feature, you can create your functionality based on that data, but you don't always need to synchronously call the other services, because that creates too tight coupling between the services. And you are running into all the trouble that we've seen before. So I mentioned before that microservices aim to maximize speed, not to minimize the cost. So they're optimizing speed, they're not optimizing cost. So does that mean that microservice architecture always means more expensive? Because ultimately, when we want to go for reuse, the thought we're having behind is we want to save cost, right? But the thing I'm always wondering about is how much cost are we saving, or where are we saving the cost? Because if we are slowing down ourselves in development, that is also costing money. After all, we are all developers, and we are also all getting, typically we are getting paid by the hour, and we are not getting paid by the number of stories we are creating. But the success is rather defined by the stories that we are creating, right? So what really matters is that we are fast, because if we are slow, that's also costing money. It might save us some money in the very, very, very long run. So at some point, we might also probably benefit from the reuse. The question is always, where's the sweet spot? And that's what many people miss. They are not conscious about. Too many people, they want to have both. They want to have a highly decoupled architecture to move fast, but they also want to be heavy on reuse. But the thing is, you can't have both. So I'm sharing with you some quotes from Neil Ford. For those of you who don't know Neil Ford, he's an architect and director at ThoughtWorks. He's also a book author and a well-known speaker on public events. And I also got to attend a workshop with Neil, and he made some very nice quotes here, which I want to share with you. And one thing that Neil said here is that one of the great trade-offs in microservices is that you have much higher levels of duplication than you would ever tolerate in previous architectures. But part of that is to get to that level of decoupling that allows you to move faster. So you see here, Neil also puts emphasis of this decoupling, because you want to move fast. And another thing that Neil also shared is that this is one of the most fundamental misunderstandings people have. They want high degrees of reuse and also highly decoupled architecture, but you cannot have both, because reuse is coupling. Coupling is reuse by definition. If you reuse something, you couple to it. From a runtime perspective, you couple to it. Sometimes you couple to it also from a design time perspective. And almost always you couple to it also from a people or organizational perspective. Because sometimes you need to change from that thing you are reusing. And that means you are having a people dependency then there, all right? So part of that decoupling, part of decoupling things means stopping reusing so much. Doesn't mean that we're not reusing at all anymore. We don't want to have like duplicate everything. That's also for sure. We gotta have a good balance, but we don't want to overdo reusing. That's the point that he wants to make. So what are now some related cloud native or DevOps concepts? So when you think back about the initial slides that I shared at the beginning, where we talked also a bit about cloud native and DevOps and all those different concepts. So many other things we know about cloud native or DevOps, they rather follow from this primary goal of aiming for speed rather than being a primary goal in itself. So for example, many people think microservices means that we can pick the technology that fits best. So for one service, you want to pick Node.js. For another service, you want to pick Java. For one service, you want to use probably a SQL database. For the other service, you probably want to use a NoSQL database. So pick the technology that fits best. But that's just a consequence of the goal of decoupling things in order to allow people to move fast. That just follows from it. So it's not the primary goal of microservices to pick the technology that fits best. It just follows from the goal of aiming for speed and decoupling for that purpose. Other things like high availability, resilience, scalability, elasticity, they also just follow from this decoupling. They're just a consequence of it. You could see I decoupled the services just a little bit. And my ad service became more available, it became more resilient, more scalable, more elastic. All those different things are much easier. Also, when you think about continuous delivery, imagine before I could not deploy the ad service individually. I had to have the other service in place, right? So that means in my continuous delivery pipeline, I have to deploy the services together. So if I'm a development team member of the ads team, that means I also have to know how to deploy and configure the review service. Otherwise, we can't get our pipeline running. We can't do any integration tests in our pipeline, right? And that's a problem because we might not only be depending on the review service, we might also be depending on some product service, on some user data service and whatnot. And if that is the case, continuous delivery will become a problem for us. In theory, all the services should have their own pipeline and should be deployable independently, but if it's too coupled, it's not possible, and it becomes so painful that the continuous delivery pipelines need to be orchestrated. And then people typically create a central team who is responsible for the pipeline and orchestrating all those things. And then suddenly you have the central team instead of doing the DevOps and the CD pipeline as part of the team. Same thing with monitoring of application health, usage, and all those different things. The more coupled things are, the harder it is. So the list probably goes on. These were just the things that from top of my head I could cite here. And these are also things that I'm seeing when I work with people who are in an organization where the services are too tightly coupled. So all these things, they just become much harder if services are tightly coupled. Doesn't mean that they're always impossible. They might still be possible, but they might become so hard that it either costs a lot of money or people just consider it not feasible. So now, to conclude it, what's your relation now to Agile Organization? And probably you already have a feeling about it, what the relation is. So the relation to Agile Organization is, when we think about Agile Organization, often we talk about scaling Agile, where we try to, manage or apply Agile principles for orchestrating all those different teams that we have, right? The teams are working in Agile mode, they're running Scrum, but we also need to have some alignments across the teams. And when we think about those things, they always aim to manage the dependencies. For example, Scrum of Scrums, or orchestrating the release planning, where all the teams get to talk what their plan is and check what they need from each other. That's all about managing those dependencies. That means the purpose of these concepts is to mitigate the pain that arises from the dependencies. So dependencies, in turn, they arise from the coupling, typically from the technical coupling that you have in your architecture. And the coupling that typically happens along the technical layers, but not only. For example, I give you some examples here. UI and server, I mentioned that before, or you could say UI and the domain layer. This is a typical thing where things are coupled. Server and persistence is a coupling point. When teams suffer from these dependencies, typically the problem is that they are setting up the organization in traditionally layered teams. They're setting up a UI team of 50 UI developers who are responsible for the UI for the whole solution of all the services. And they are maybe setting up a team for all the persistence, for all the domain developers, the server developers, and for all the DBAs, all the people responsible for the persistence. So now you have those people in different teams organized along layers, and you have the dependency between those things. The dependency is there, you can't get rid of it. But if you organize your team among those technical layers, you will suffer from these technical dependencies. So better put them together. Another example is sales order versus product data. This is a runtime reuse instead of eventual consistency and async. That's pretty close to what you have seen before. So in our setup with the add service and the review service, we did not have this coupling problem here, because in our ad service, we had the UI part, the server part, and the persistence part. So the people in the same team are working on the things together. So they don't suffer from those dependencies because it's inside their team. But they suffer from maybe a dependency to another service which provided some data that they needed. And in the initial solution, we had a runtime reuse instead of applying eventual consistency and async. And we improved that later on during the demo that you have seen. Another example, and here we are going to the DevOps area, is there's also dependency between the code and the infrastructure. And there's also dependency between the usage data and the code. So when you have your infrastructure code, this is scripts that deploy your service. And the scripts that deploy your service also depend on the code somehow. Maybe the code needs a database. That means you also need to make sure in your infrastructure that the database is provisioned properly in your cloud environment and configured properly. The database connection needs to be set up correctly for your cloud environment. All these different things are part of the infrastructure. And this is coupled to the code. If you choose to use a different technology for the persistence tomorrow, you also have to make adjustments in your infrastructure. Same also with usage data and code. Same thing, if you want to monitor how people use your service, the usage data also depends a bit on your features. And it also depends on your source code. So when these dependencies are there, the thing is just, if you set up different people responsible for the different things, you have a people dependency or a team dependency in that case, and people will struggle with it. People will suffer from that. In this case, you would say we are doing dev and the other people are doing ops. So we are dev, we are taking care of the code here and the code here, and the ops team takes care of the infrastructure and the usage measurement. But then whenever we change something, we need to align, and we need to align our plan and check whether the plan fits. So we are doing dev versus ops instead of doing DevOps if we have set up our organization like that. And again, the list probably goes on and on and on. So that means if microservices is done right, it means to reduce or relax those dependencies. We need to organize people along the value stream, organize along the business domain. That means we have our service, our data, our UI. You could also say this is our usage data, our deployment pipeline, and it's also our release decision. When we want to deploy to production, we should be able to deploy to production. Maybe there might be business reasons sometimes behind. And in some cases, you might also have a few dependencies where you also cannot help, but you need something from the other team and from the other service. That's fine. But it should not be the default case. It should not be like the 90% case. The 90% case should be that you can make your own decisions and you can make changes and you can just move forward without always depending on someone else who is outside your team and has a different agenda. That means the result, if you do that right, is we have less need to manage the dependency and the team is truly empowered. If that is not done, the empowerment only exists on paper. So when we get to talk about Agile, often people say Agile means that we empower people. And people say, yes, they can make their own decisions. They can make their own decisions on their backlog. But the problem is, if they have all these dependencies, you can tell them they can make their own decisions on their backlog, but in practice, they can't because they have the dependencies. So that means even if they are theoretically empowered, it's not possible in practice due to those dependencies, due to that coupling. So of course, the reality is you still want and you still need also some sort of alignment. After all, we're working on something together. If we are working on a bigger solution, there will be discussions about what makes most sense from a business perspective. How can we make revenue with our solution in the future? And we need to have a talk with all the teams, all the product owners from all the teams, and check which plan makes most sense, for sure. So there needs to be some sort of alignment. But if we do things right and have really reduced and relaxed those technical dependencies, and people have much more room to maneuver and much more space to really make their own decisions, then the pain we have is much less, and the agile events, all those things in order to manage the dependencies, is much, much, much easier. And that's how it should be. Good. That brings me to the closing statement, and then we would roughly have 15 to 10 minutes for questions. So the closing statement would be that, does doing microservices right mean that we leave everything to the teams and nothing needs to be aligned anymore, and everything will sort out magically and that would just be good? Probably not. There are still dependencies that also arise from the business, because after all, the microservices are part of an overall solution. So we definitely want to align on the business strategy. If we don't have to align at all, it probably would mean that we are not working on the same thing. But if we are working on the same thing, on the same solution, I guess there might always be a need to do some sort of alignment. We should just be more aware of the true goal of microservice architecture to make the right trade-off based on our business goal. So we got to think how important is really speed and how important is reuse. And if you think about the cloud, then it seems that most of the people in the cloud are aiming more for the speed, being fast and capture a market and capture a marketplace instead of accumulating reusable assets. And in the best case, we make smarter decisions and eliminate team dependencies that arise from technical layers and other things, so that we can really focus on aligning for business reasons, not for technical reasons. Okay, that brings me to the thank you slide already. So thanks for having me here, but we would also first, of course, opening up for questions, and I would also stop the sharing. And maybe DJ, you can help me.
Of course, thank you, Jens. That was awesome. I was spellbound. I mean, I was panicking because I was listening so intently to what you were saying that I was thinking I need to write down the questions and I need to do all this and press all the buttons and everything. So yeah, absolutely superb. So thank you so much. We've had some really good questions. So let's go through them. I think we should be able to cover all of them. I hope so. Anyway, so. Well, one observation, first of all, was from Zeitiger when we were talking about dependencies. Zeitiger says the most problematic dependency is arcane knowledge that only exists in the brain of some, in particular, if this is needed rarely. Okay, so that was a really good observation on top of what you said already, Jens, right?
Yeah, that's true. And I would say that that will probably always be true. I mean, I would even say maybe this problem would not even be addressed by the microservice architecture and decoupling. I tend to think this is sometimes also a problem about how people collaborate. It's more about those extreme programming values, sharing the knowledge, working also together from time to time. Yeah, it's true. Yeah. That's also a big problem I definitely see. And unfortunately, this is not being fixed by what I've shown before.
No, I think you're right, and your reference to XP, extreme programming, and pair programming, and that's a really great way, for example, of mitigating that sort of cathedral of knowledge only in a few people, right?
Yeah, sometimes I even have the feeling that people struggle so much with those dependencies and figuring out those things, how to deal with things from APIs, from other services and team dependencies, stuff like that they just don't have the time to collaborate closer within their team,
Yeah, exactly. Okay, so the first question came from Peter Janssens. It was in maybe my favorite part of the presentation, which is where you introduced the asynchronous message bus. So Peter says, and it's a very good question. They're all very good questions. Do we now need resilience in case the event queue is down?
Mm-hmm. Yeah, it's a true thing. Whenever when you introduce some additional technology, it creates not only a dependency on that technology in turn, because now we are depending on the message queue technology, right? Fortunate thing is that the message queue technology is a bit more generic. So therefore there is probably less less struggle with those kind of people dependencies and needing new features from the message queue because it's more generic. But yes, resilience might also be a thing over there. That brings me back to what I've shared before. Depends on what your strategy is. If you have a need for being consistent over time, you could also think about other strategies. For example, fetch the reviews information or fetch the rating information rather locally in the ad service in the background, and don't use a message queue. Then you also don't need to monitor the resilience of the message queue. If you are sending through the message queue not the raw reviews, but rather the average ratings, you probably also do not need to worry so much about the resilience for the message queue, because after all, if the message queue comes back to life at a later point in time and you get another update, it will get consistent a little bit later, and you don't need to monitor the message queue too actively. But depending on what you need to achieve and depending on how you implemented it, you might also have a closer look at the message queue and be forced to also monitor it actively. And then you also have to check what's the best trade-off over here. What do I really want to achieve? Can there be other solutions where I don't need to actively monitor those things that much?
That's a great observation as well. What's the best trade-off? Because what I picked up from your what you were saying as well is that there's real life which is also incorporated into this whole equation, right? So for example, eventually you said eventual consistency is also part of real life. So this is not something that's a purely technical play. We've got to think about what happens in the real world as well. So that makes a lot of sense. The next question is a quite simple question from Andrew Diaz, but then Andrew asks another question, so we'll do the simple one first. The demo Node.js based app that you showed, would it be possible to share that in an SAP samples based repo, for example? Because not only Andrew, but I would also love to play with that.
I think that should be possible, yes, because we are just using standard technologies here. Yes, I think that should be possible. Yeah.
Thanks, Jens. So just a point to Andrew, creating a new repo in SAP samples, that takes a short time, but so it won't be immediate, but watch this space. Let's say that. So the other question from Andrew, which I thought was a really good question as well. Andrew says, when you were talking about domains, technical domains versus business domains, how do you define a domain? To back that up, or to add value, add information to that question, he was saying, for example, he would see a review as being part of an advert, not a separate service, right? So, and then that thought came up to me as well when you were talking about sales orders and product data.
Oh yeah. So that's actually even like two questions. I think the first question: how do you go about these business domains? How do you identify those and make sure that you have the the right layout of these business domains? There's a discipline called domain-driven design. Maybe some of you heard about that, which has the thought behind that you start really from the business. You start with the events typically, then you also think about the data of the events, and then you try to also group the events and the data in such a way that you have asynchronous events between those contexts, and also minimize the data redundancy. So you start basically from the business. So you identify the business domain by starting from the business events first, check what business events you need for your solution, and then start to think about the data and how can you have the events and the data, and where can you have the eventual consistency. There is a whole universe on domain-driven development. There's a lot of books and people who run workshops on domain-driven design. I think the key of it is really to bring the business people and the developers together. Yeah. And sometimes it also means you need to try out things. Sometimes you don't even know. And the biggest problem sometimes is it also changes over time. So you might think that today the reviews and the ads probably belong together in the same domain. And you know what? You might even be very right about it. So what I've just shown over here is just to give an example and a starting point, but I'm not saying that it was even a smart decision in the first place to put them into separate services at all. People like Martin Fowler, when you hear about some talks from him, or Sam Newman, who has written a famous book on microservices, they even recommend to only carve out a service which you really can't handle in the monolith anymore. Because in the first place, most of the things are easier to handle in the monolith. Integrating things, making calls to other things are much easier inside a monolith. You don't have different deployment pipelines and things like that. They rather recommend start worrying about those things when you have a problem that you cannot really handle in the monolith any longer. And by that, usually you have also a much better understanding about your domain and where you are heading in the future with your business. And then you might really have a good picture on the question and a good answer for the question on whether the ads and the reviews should be separate services or rather not.
Great answer. And in fact, I do remember, I think it might have been an SAP Inside track. Generally in SAP community, there has been some talk about DDD, domain-driven design. I do remember a talk, I think it was by Fred Verheul and Tudor Riscotti. Please correct me if I'm wrong in the chat, but yeah, they were the ones that introduced me or opened my eyes to DDD. So it's really nice that it crops up again. So we've got another question now from Umut, and I'll just read it verbatim. ERP systems consist of highly interdependent processes. What are the disadvantages of using microservices architecture here? Is it worth sacrificing it for speed?
Yeah, that's exactly the question that you gotta ask yourself, and there is no perfect answer for that. If the things are, what I've also seen is sometimes that people, they have a bunch of tables or a bunch of schemas in the database, and they just try to make this a microservices, which basically means to just smear your code basically along the database schema. In that case, it's probably not going to be helpful. The number of problems you're going to create will be just bigger than the number of problems you're going to solve in some situations. So no, that's not always the best thing to do. Sometimes you're definitely better off in a monolith, especially if you're like a small group of people, let's say like 10 people, 20 people, and you don't have this need for really decoupling and scaling and have splitting those 20 people into 2 times 10 people and moving as fast as they can, then probably just don't. Probably just don't. Because
Great
what
answer.
you will lose is what you will lose is, for example, transaction. Database transaction is a thing you lose immediately. And if the things you are trying to split are not clearly decoupled and you have pain with this eventual consistency, then better don't do it. If the pain you're getting from the eventual consistency is bigger, that typically indicates that the things you're trying to split up should not be split up. Because from a business perspective, maybe they are too close to one another. Then just don't.
Fantastic. Yeah, I mean, that says to me that like anything else, that a microservice architecture is not one single golden magic hammer, right? You have to really think about what you want to achieve.
Yeah, the term micro is maybe what creates most misunderstandings, because after all, it is not about the size. It's more about cohesiveness from a business perspective.
That's a great point. Yeah, it's not about the size. Yeah, that's interesting. I've always thought of microservices as small, but yeah, absolutely right. So we've got 2 more questions. We've got some great comments here, by the way, as well. I'll let you read those in the chat later, Jens, but all very positive. So Nigel James asks, does microservices increase complexity, more moving parts, ?
Almost certainly it does, because you're getting a distributed system. Absolutely. So think about the monolith. When we got to integrate between the ads and the reviews inside the monolith, we can just make an API call, right? Just call our little API directly, call the code, call the public method, call the interface, whatever, just call it. And it's in the process. That means when you think about testing, it's very easy, because you can just have a little component test or a little integration test sort of to verify that things are working well. But when that's in a distributed system, you can't do that easily in an integration test, right? You can deploy both the services and test them in integration, but if you deploy both the services, which versions of that service are you going to use? Because they can be different versions. It can be the old version, the new version. What do you deploy where, and how do you test them in those combinations? You can't have a perfect answer on those things. And then it's still a distributed process. So it creates much more problems. People then aim for contract testing in that case, which then addresses this problem of the distributed system. So you can also still have a good test automation, but it's much harder to write and much more effort to write it and much more effort to maintain it. than a simple integration test. So that's another trade-off. Almost certainly it's getting more complex.
Great stuff. And we've got time for one more. I'm just looking at the clock now. Got time for one more question. This is from Uwe Fetzer. Are there, nicely done, Uwe, are there best practices to document microservices?
Yeah, well, best practices. I mean, where there's a best practice, I mean, that's hard to answer. I tend to believe there are probably some certain common practices or good practices. What I've seen out there is, for example, people use Swagger for their API definitions. It sometimes also can help to have some very quick schema-like validations for your endpoints and things like that. So that's what many people like, to use something like Swagger to document the API and also get some kind of some verification for free out of it, like a schema validation. Yeah.
Great stuff. So we're just hitting the top of the hour. Thank you so much. So thank you everybody for joining and listening and making comments and responding to Jens's questions and also asking your own questions. It's fantastic. This is what we love in Devtoberfest. Jens, do you have any final words before we say goodbye?
Well, no, only that I really enjoyed it with all of you, and I enjoyed the questions very much. So had a hell load of fun, and wish you all have a wonderful day.
Thanks very much. Thanks everybody, and thanks so much, Jens. I'm going to end the stream now. Bye for now.
Bye, everyone.